checking chapter 7 review. We'll check chapter 8 in a second. I'm talking about the final. Someone asked me really quickly. On a normal chapter test, we have 1 page front and back, right? 15, 20 problems max. Usually like 15-ish. Okay? So if that takes us usually about 40 minutes, some of you 35, 40. Some of you take the whole time, but a lot of you finish early. Then think, if we have a little bit less than 2 hours, then it'd be like 2 or 3 times that. So probably the final will be about 3 pages, unless like maybe multiple choices, a couple pages, and then long answers, a couple pages. So it's going to be about 2 times the normal long answers that you have, probably like 2 pages front and back-ish with like the long answer worked out. Unless I want to give you a little more space for work, then maybe 3 pages. Multiple choice will probably be 1 to 2 pages front and back. So that could be anywhere between, let's say 15, 45, probably about 50 questions. Math takes time, so I can't do like a 200 Bible just for 30 pages, or like English, or you know.
You should do it multiple choice. Wow.
Yeah, but you can't go that fast enough. And if you do, you'll give them all wrong. You know what I mean?
Just like yes.
So, all right.
I say 5 questions.
Let's go ahead and check chapter 8 real quick. Here, here's chapter 8.
I got a picture of it.
Okay. Oh, chapter 8.
Maximum 10 questions.
I'm trying to get so you guys can see it. The problem is, I don't know if I do that, you don't know one. You miss 1, you go from an A to a B. You miss 2, you go from a B to a C. You miss 3, you go from a C to a D. That's not good. Oh, I thought you said 10 questions. 10 questions. Yeah, right? It would be like, oh, I missed 1.
That'd be
You guys see these comparative words? Listen. Can you squish that table down and write what you need to know on your note card?
Yes.
Yeah. The comparative words: shrink, stretch, shift.
We like to.
my card. Can you go front and back?
Yeah, front and back, totally fine. Just has to be handwritten.
Can we write like the vertical translations?
My advice would be, because the final is going to be, well, there's the multiple choice and long answer, but each of the separate portions will go in chapter order. So that way, if you put your note card in chapter order, chapter 5 stuff, 6 stuff, 7 stuff, you know what I mean? You'll be able to kind of be going in the same order as the final. So that's going to make it easier on you too. Don't just like go randomly picking stuff, or else you're going to be doing this the whole final. That should be stressful. Aiden.
Well, if you can't put 18 on one, no card can you have like multiple in the range?
No, you just have to kind of plan it.
And it's chapters 5 through 10, correct?
Only one?
Technically, it's the end of chapter 5, but a lot of you guys are like substitution elimination isn't that bad. I wouldn't mind, they're not that bad. Concept on chapter 8. But I can say you can write down formulas for quadratics and things like that. You guys are allowed to have a calculator on the final, but
No.
you are allowed to have a calculator on the final. But if I were you, I would figure out the calculator you're going to use, ask a friend ahead of time, like maybe borrow it on Friday because your friend doesn't have a math final on Tuesday. Have it ready so that you don't need to stress about the day of. I do have a few up here, but as you guys know, some of you get like the calculator's not very good. So if you can make sure to have a nice calculator the day of, then let's go ahead and do that. Johnny, go pull your desk up to where Jazzy leave that desk exactly where it is. All right, cool kids. Let's go ahead and you scroll down. There are just a few more problems from chapter 8. If you want a picture, go ahead and grab it now. I'm going to get ready for the questions that you guys have from chapter 6. Let's start there. Some of you guys didn't have it done on Friday, but maybe you do now. Any questions that we need to go through for chapter 6? I'm going to write down all of the questions right now.
If we finish our questions, like just curious, if we finish our questions,
You may start working on 9 and 10 if you're caught up to chapter 8, but just keep them, keep them. Headphones, you may have it in one ear. That way, you should be able to hear if it's being,
just in case.
or if I'm like, hey, pay attention.
Can I ask you a quick question on 6?
Yeah, questions on 6.
Number 5.
Number 5. Any other questions on 6, Diego?
12.
5 and 12? We didn't do that one on Friday, right? I thought we did 12.
No, yeah, we did.
Well,
Oh, sorry.
It's okay. Diego, check out the video from Friday at the very end. Which one?
13.
Oh, 13? Okay. Jordan, go ahead.
I just have a super quick question. On the chapter 8 for 8 and 9, it was asking if it was actually quadratic or linear. I can't remember what it is for the difference between quadratic and linear. What
Linear, you add,
or subtract.
and there are patterns like that for quadratic. quadratic is this weird constant second difference weirdness. What my advice was,
What was the case of one like that?
my advice was just to plot the points. And remember, a linear is just going to be going the exact same distance apart in a diagonal, or it could be, I guess, vertical or horizontal line. Quadratic is going to have a down and an up, or an up and a down. Exponential is just going to be swooping one way.
You mean parabola? Okay. And,
You might not see the whole
and
parabola.
exponential just grows super fast, right?
Yeah, only one way though. It doesn't have like a disk or a rise to it. Any chapter 7 questions? Rob, go ahead.
It's gonna have to be from
Yeah, stop making it. I see you see you. Stop please. Don't need to. Which one? Okay, number 3. Any more chapter 7? Okay, you just said.
Oh, number one.
Wait, number what?
Number one.
Number 1. Alright, anything else from chapter 7 going once?
Number 10.
Number 10. Anything else? Caleb, did you not number 6 from chapter?
No.
Yeah, sorry, from chapter 7. I'm getting the
Oh,
questions all ready to go. Alright, any from chapter 8? 4? Yeah, any more?
Will we allow them to have a calculator on file?
No.
So no, we'll say calculator.
Normal standard calculator. TI 30 series and great. Sorry, Justin, you said number 4, chapter 8. Any more chapter 8 around the room? What went on with that? I know, but no.
I'm gonna just see what they have to do.
Okay, how to do degrees. I'll put a quick note so I can make sure to do that. Alright, cool kids, let's go ahead and start with chapter 6. Degrees. Here we go. No, you can stay in your seats because I don't want people to like move back and still be able to come front. They can't have a headphone in one ear and be working on the future. If you don't need questions. The headphone only in one ear if you're not tracking along with us in the questions. Alright, our first question on chapter 6 was number 5. Let me go ahead and zoom in on this one so we can see it. I hope my iPad starts working because it has
I got confused on this one because of A,
Alright, kiddos, Saturday night to go to the whiteboard for the first couple examples just because my iPad isn't working, as I've already said, my smart board stopped working this year as well. Yay! Okay, I know. Johnny, can you go ahead and read number 5 for me? What's the problem?
B
B,
to the power of negative 5
Johnny's got it, thanks. Over.
over A to the power of 0, B to the power of negative 8.
Okay. And the directions are to
Right,
simplify and write. She's got it. Would you mind going to Mr. Rogers? Is that too much? Ask us his hand and be like, Alright, so kids, positive exponents. Question, which of these exponents aren't positive already? Okay, so negative 5 is not positive, negative 8, alright. We're done. If anybody makes noise and I catch you, your head is going down on your desk and time's up. Too bad. Hopefully you didn't need to study for the final. For today at least. I'm serious. Head down on your desk. Summer school, here we go. Let's focus, let's be quiet. So I have to do it up here and I'm trying to help. So I have negative 5 as a power, I have negative 8 as a power, and I have 0 as a power, okay? Question. What is the general rule when I have anything to a negative power? I'm just going to say negative C. How do I rewrite something? I switch. Now, where is this right now? Because there is no top bottom. I don't see a top bottom.
1.
I can say over 1 and I can say it's on top.
Yes.
So if it's on top, where is it supposed to go?
1 over
Bottom. So we would put anything in the bottom and then the 1 would be on top. Now we're not just switching. Let me go ahead and change this just a little bit. Let me put a 2 just for sake of argument. Okay? If there was a 2 in the bottom, the 2 would stay. I'm not switching. What I'm doing is taking this expression, I'm moving it to the other position. Instead of numerator, I put it in denominator, and I change it to a positive exponent. What if I have something like 2 over x to the c with a negative? What if it's in the bottom with a negative exponent? It comes to the top. Who else is going to stay in the top?
2.
What's going to be in the bottom?
1.
Now, can I write this to be a little nicer? Yeah. We don't usually keep things in the bottom, so it'd be 2x to the c, right? So let's use this idea. Let's use these rules to go ahead and try to properly write this expression. What am I going to do with b to the negative 5?
You're gonna switch it down.
It's going to go down. What are we also going to do to b to the negative 8?
Switch it out.
It's going to go up. Remember, when I switch, the negatives go away. So with that, kiddos, let's see if I can. What are we going to do with this guy?
0. 1. 1.
We can leave him in the bottom, but the struggle is a to the 0. That's actually something we're supposed to be able to do. Does anybody know what anything to the 0 power is?
0. Wow.
It's 1, and 1 times anything is itself. So the most simplified answer would be, wait a minute, I have b's up top and b's down bottom. I can reduce those. Now, there are a couple different ways of doing this. We did talk about an exponent rule that said, if I have x to the a over x to the b, when there is division, like bases, there is a special way of simplifying. What do I do with the exponents? I add them when I'm multiplying. What do I do in dividing? I subtract. The top one minus the bottom one. That is one way to think about this. So when I come over here, they have the same base, and I can say b to the, where I do 5 minus 8 or 8 minus 5.
Minus 5.
Is this something you can put on your card? Maybe it's a good thing to like have a scratch piece of paper and start writing down cool things like this. So it'd be b to the 8 minus 5. Johnny is right, that is b cubed. Now we're done. This is a multiple choice question. Here's the problem. If this is a multiple choice question, you would have to get all the way to the end. If it's a long answer question, as long as you simplify correctly, maybe I could give you points for getting partway there. Does that make sense?
Yes.
Okay.
So the a to the power 0 is
A to the power 0 means 1. Don't say nothing because that's a 0 and I don't want you to get messed up. But it means 1. There's one other way of thinking about this that might be easier for some of you. You could think about it as, how many b's do I have? 4, 8. How many b's are being multiplied together on the bottom? 5, right? What can I do when I have 5 over 5 or 10 over 10 or b over b? They reduce to be 1. So therefore I could reduce. How many are left? I did too many. Hold on. 1, 2, 3, 4, 5. How many are left? That's why I have B. Yeah? Jazzy, come on back to the front. Didn't work.
I'm not that.
Come on back to the front. You don't need to say anything. It's okay. Thank you. Alright, kiddo, so we have that question done.
Can I plug in my house to my iPad?
As long as the iPad's not out, you're not watching anything else. Alright, cool. Okay, so the next question that we had was number, I think, 12? I think it was 12.
Yeah, no, 13.
13, thank you. We already did number 12. Number 13 asks us to graph and to compare, describing the domain and range. It's a very loaded question, I understand that, but we can go ahead and get through this one pretty quickly. Once again, sadly. Okay, number 13. How do I graph? Guys, what have I been teaching you all year how to graph? the sides with basically everything but lines. How do I graph everything but lines? So we're supposed to do number 13, we have to graph something. If worst comes to worst, you have no idea what to do, what can we always make?
Table.
Always.
Table.
Make a table. When we make a table for number 13, at some point we have to kind of just pick a number to start at, choosing an X and plugging into a Y. Oh, we just have an X. Oh, we have F back.
Yeah.
And our equation is, Justin, can you read it to you?
Y equals 2 times 6 to the power of x.
No,
Yeah,
it's,
sorry.
no, it's
Yeah,
outside.
thank you. Where do we normally start a table? What do you guys think?
To plug it in.
Two.
Yeah, we could do -2, -1, 0, 1, 2. Do you guys see how though? Does a -2 up here?
No,
Is that gonna be nice?
no.
No. 0 is probably a good choice, but let me go ahead and choose -1 just to show you guys how negative numbers do work in what we call exponential functions from chapter 6. If we were to plug in -1, f of -1, that's function notation, we would have 2 times 6 to the -1. Now, if you guys look, I know it's kind of tricky, the 2 is outside, he's just times, no big deal. 2 to the 1 times. 6 is to the -1, so I would do 2 times 6 over 1.
One
The
over
6
six.
goes exactly in the denominator.
And it's one,
What's 2 times 1, 6?
one
One.
over three.
I mean, one.
No, you're okay, you're okay. 1/3, just push over 1. You just saw the 2 cents.
I'm stupid.
Now, I could go ahead and do like 0, maybe 1. I just want to get an idea. What happens when I go to plug in 0 to a power? We gotta review. Anything to the 0 is it's 2 times. This becomes a 1, which is just 2. Now, the nice thing is 1 is usually an easy number to plug into a power. What's 6 to the 1?
6,
And what's 6 times 2?
12.
Now, if you guys notice on our tables, isn't anything higher than 12 usually going to be off the table? Or off the graph, I should say. So
No,
we'll kind of stop there. We could go higher, but our numbers are getting big. So as we go to graph number 13, I have -1. Oh, you're going to have room up here. I'll move it down. 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay. -1 is going to be 1/3, which is a little tiny way down there. 0 is going to be 2. 1 is going to be 12. That's 11. You guys remember how exponential functions work? Is it a U, like a quadratic parabola? Is it a line, like a linear? What's an exponential look like?
Then they go straight up.
It goes up. Remember, it says, there it is. That one.
Like it goes small and then it goes yeah, like that. Like an airplane.
There it is. It only goes up one way. Parabolas are the U, or the valley, or the mountain. Exponential slope. Now, what would be, help me out, what would be the domain? Domain, what is domain? Is it X and Y?
Y.
Exit.
Domain X and range
I
Y.
know X.
Yeah. Domain X and range Y. Domain goes with X's. What question do we ask with X's? How up, down, or how right, left?
Right, left.
How right, left. So question, how?
I'll get it.
How left
I'll
does it
get
go?
Then it eventually goes
Forever, right? Isn't it just gonna keep going left, 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 left? So we could say super snazzy. We could say negative infinity is on the left and what's on the right?
positive.
Yeah, we could say super snazzy interval notation, or we could just say all real numbers. All real numbers. Now, if domain is how left, how right, then what's range? can say for x's and then range is for y's. How low does it go? Johnny just said it. How low does it go? 0. Does it hit 0?
No.
It's going to get closer, but it's not going to hit. And it goes up from 0, so what inequality am I going to use?
Greater than.
Greater than? I have the domain, I have the range. If we want to be really spiffy and use our comparative words, when they ask us to describe or to compare, we could say there's a 6 to the x, that's who we're comparing it to. This one also has a 2, and it's a 2 on the outside. If you look at your table, a 2 on the outside is going to mean that this is going to be a vertical stretch by 2, or by a factor of 2. Alright, kiddos. Chapter 6 is done. Let's go do chapter 7. You guys had a few questions on that one. Careful. Chapter 6 exponents can get really, really tricky. Give me 1 second, Jasmine. Chapter 6 exponents can get really, really tricky.
Yeah.
Yeah.
Okay.
Yeah, tell her to go to the office. Because as soon as she gets in the office, they'll send you a note. Yeah. Or she can call in the office. I just need you to know. Alright, so for number 7, you guys had, what is the question? Okay, 1, 3, and 10. For number 1, combine like terms. First of all, question. What is this called when there are only 2 terms? Binomial minus, what's it called with 3 terms? So I have a binomial minus a trinomial. True. Okay, so with my binomial minus a trinomial, I'll come over here on this side. It's not for you, Jazzy. I'll send it to you. Alright, Griffin, can you read me number 1, please? Oh, okay. Okay, keep going. Okay, so we just said we have a binomial minus a trinomial. You guys are tracking, following along. Your eyes should be over here now, okay? A binomial minus a trinomial. The name of the game is combine. You guys finish. Combine what? Combine like terms. Combine like terms. Now, in order to combine like terms, we need to get rid of parentheses. Question. Kaylee, what's in front of parentheses if nothing's there? Good. And we're going to distribute that 1 to each. Yeah. Well, if there's no negative in front, then yes. So 1 times negative 2p is negative 2p. 1 times 4 across addition is 4. Now, Angel, what number is in front of this parentheses if no number's there? It's a 1. Good. But there's also a negative. I'm going to go and make that a plus so we see the negative 1. If I distribute negative 1 times positive p squared, I get a minus p squared or a negative p squared. Then I get a negative times a negative is a positive. Good. And I get a negative 8. Now I just went ahead and said plus a negative to make it easier to combine. Question. What are my like terms? Okay, good. I have a p term there, a p term there. Are there any other like terms?
Oh, I meant, yeah, 4.
Good. I have constants. Now, when we, well, let's go ahead and combine first. How can I combine negative 2p and positive 6p? Adding. So 6, negative 2 plus 6 is 4. So I did these ones. Now how do I combine the 4 and the minus 8? 4, I'm just kind of moving. 4 minus 8 is a, good. And then what do I have left? Now, guys, this is good math, but wrong order. How do we write polynomials? Descending. Good. So we do the negative p squared first, then what? Because we have a positive 4p, and then done. Done. Yeah. What else they ask? Then identify the degree. Ooh, someone had a question on degree. Yeah, Ian. Here we go. Let's talk about degree. Now that I have this all combined, or even earlier, I need to look at every single term. And I need to say, hold on. I'm going to talk about, first of all, how do you find degrees of each term? And then we'll talk about how do we take those degrees and figure out the degree of the whole polynomial. The degree of this term is all the exponents added together. Now there's only one p, and it only has one exponent of 2. So the degree is just 2. What's the power, the exponent of this term? P is to the first power. There's only one variable, and he just has to the first power. Figure out the exponent. So I have 2, and then I have 1 when it's a p alone. Now, is there any variable with this 4? So we can say, kind of, there's a 0. We don't see it, but we can say there's a 0. Now, this is how to take the degrees of terms. How do we compare those and find the degree of the whole polynomial? No, don't sum. The highest wins. The highest wins. 2 is the degree of the whole thing. Wait a minute, we kind of know this. A quadratic has a degree of 2. Why? Because we always have a square. 5x squared minus 2x plus 1. The degree is 2. We just picked the degree of the highest. The highest degree wins. You guys had a question on number 1, but you also had a question on number 3. Wait, what's the other thing that we're supposed to do? Oh, number of terms. What does it end up being, guys? A binomial minus a trinomial ended up being a trinomial. Good. That's the one thing that we didn't answer. So you guys help me out with number 3 because you just saw me do an example of number 1. Question, what's the very first step? Good. Get rid of those parentheses. The only way to get rid of the parentheses is to put a 1 in front. So go ahead and Angel, can you read off number 3 for me? Yeah. To the power of? Keep going. Oh, ST, sorry. ST plus. Good. So, you guys said put the 1 in front, and that was an excellent first step. Positive 1 in front, and then this one's going to also be a positive 1, so just plus. Dylan, sorry, pay attention. Now, what do I do with numbers in front of parentheses? Good. And since it's a positive 1, can't I just rewrite everybody and they stay the same? Okay. What am I looking to do as I get rid of my parentheses? What do I want to do next? Okay. Combine my terms. So I have, let's see, I have s to the 4th. That's a guy. Good. I have, ooh, that's a negative 1, huh? And then I also have, yeah, I got that too. Okay, so I'm going to go through and take them one at a time. So the s to the 4th, I have 4s to the 4th plus 2s to the 4, which becomes what? Good. So I have 6s to the 4th. Those are done. Now what? Yeah, Johnny went straight to the t's because what's 2st minus 2st? 0. So those cancel. It just becomes 0. Then I have 1t minus 4t, which is negative 3t. Now, we could have done this earlier, but I'll do it now. What is the degree of this term? Good. That's the exponent. What's the degree of this term? Good. Now, this isn't necessarily, well, it's not necessary right now, but does anybody know what the degree would have been of For instance, the ST term. You would think so, right? But it's not, because he has a 1 and he has a 1. So in one term, we actually add, that's why I wanted to show you. In one term, we add the exponents. So in this term, we think of the degree as being 1 plus 1, which would be 2. Now, does it end up mattering at the end? Who's still the highest, whether or not we look at him? Yeah. So what's the degree of the whole thing? 4. But there's one more thing that we didn't write over there, but I still asked you because it was part of the question. This was a trinomial. Good. This is a binomial. Trinomial, remember there are 1, 2, 3 terms, like a tricycle. Oh, we just call them polynomials if it gets any bigger. So 4 terms, 5 terms, 6 terms, 10 terms, 20 terms, they're all just called polynomials because it's easier just to have them. All right, we have one more question from chapter 7. That was number 10. Ooh, that one's a mess. Number 10, actually, I have to review the writing.
Yeah, that is pretty bad.
Because remember, I wanted to try to make factoring a little easier, especially with the final coming, but 8 is still a question. Yes. No. Just add them. So, remember, we're not looking at the numbers, we're looking at the variables only. Taking, because the power, the exponent of the variable was 2. Oh, remember, the biggest one wins. So the highest bidder wins. Think of it that way, the highest bidder. So the highest one was 2. Over here, the highest bidder was 4. Is that cool? So you come back. We want to do some factoring, and I want to make it a little bit easier than it was before. What's the difference between numbers 9 and number 10? How many terms does number 9 have?
3.
Good. And what do we call a polynomial with 3? Good. Trinomial. How many terms does number 10 have?
4.
Number 10 is a little harder. Okay, listen carefully. We're in what chapter right now? Chapter
7.
7. Chapter 7, we're going to pick up with